Hello and welcome to our virtual trade show, this time in English for our international listeners and visitors. Today I will talk a little bit about industrial cleaning, especially industrial foam cleaning in the food industry. And I will kick off with a little presentation. My name is Bernard Bobusch. I'm one of the co-founders of FDX, and let's dive right into it. We will start the presentation with a little introduction about ourselves, about FDX. We will show you a little bit about the background of industrial foam cleaning or industrial cleaning in the food industry, as you can see it on the right side of your screen. I will show you the relevance and the role of the nozzles, how to use the right nozzle, and how the foam cleaning really does work. I will show you the state of the art, what is currently used, and what is our new nozzle proposal, our OsciJet MPX-CS nozzle line. About FDX, we are a young company. We were founded in 2015, and we mainly focus on OsciJet nozzles. You can see it here on the left side of your screen. We have different nozzles. So the large one is a pressure washer nozzles for industrial pressure washing. We have our medium pressure or industrial cleaning nozzles, the little bit smaller one on the left. And we have a lot of different other nozzles for example, for agriculture and for pressure washing, for lower flow rates and other applications like cooling towers. We were started 2015 in Berlin with 2 colleagues and myself, and we have now 7 international patent families. So we have a huge know-how database on which we develop our nozzles. And we develop our nozzles completely digitally. We have a very good background in flow simulations, in computational fluid dynamics, and so we develop and optimize our nozzle at the computer, and then we come here to our lab and we test them. And I would like to show you today what we do for the medium pressure cleaning and for the foam cleaning, especially in the food industry. In the industrial cleaning, and not only industrial cleaning, in cleaning itself, nozzle play a very important role. You can describe every cleaning application that you have with a so-called Sinner circle. Sinner was a German around 1900 who described a cleaning task that always needs or is dependent on 4 different factors. So there's the factor of temperature. As you know, hot water or hot surfaces cleaning better most of the time. It's about time, it's about chemistry, and those 2 mostly go together. So if you have chemistry and you need to let it sit on the surface, so you need the time that it can really solidify the dirt into the cleaning solution. And you have the mechanic part, which can be done by brushes, for example, or by higher pressure. And in the Sinner circle, nozzles are the main factor for the mechanic cleaning portion. If you go for spray cleaning, for example, pressure washing, the nozzle is the one thing that really creates the mechanical power on the surface. The pump creates the pressure, no doubt about it, but without the nozzle, you won't have the power on the surface. So the success of cleaning is always dependent on these 4 factors in the Sinner circle, and the nozzles are one of the main factors for the industrial spray cleaning. The role in the nozzle, as I described already, is to transforming the pressure energy that you have from your pump. Is it medium pressure at around 20 bars or is it high pressure, into velocity. So to speed up the droplets and to give the droplet the right kinetic energy to impinge on the surface and remove the dirt from the surface. They create the desired spray pattern. So for example, in a fan nozzle, you have a line on the surface where the water hits or the water droplet hits the surface. You have circular hollow cone nozzles that create a circular shape, and you have full cone nozzles, you have jet nozzles. So the nozzles create the desired spray pattern for your application. The main parameters to describe the nozzle are the droplet sizes, the droplet velocity, the spray angle, and the droplet distribution. So those are the main factors that we use to develop and to optimize the nozzle to your system. One of the biggest factors for you as a user and for somebody who is designing a cleaning machine is the nozzle capacity. The nozzle capacity describes the nozzle performance. So it describes the dependence of pressure and flow rate of each individual nozzle. Other words or other notations for the nozzle capacity is the nozzle caliber or the nozzle size. Nozzle size is always a little bit tricky because, as you can see on the left, the large one has a smaller nozzle capacity than the a little bit smaller one on the left side. So the nozzle capacity is not associated with the nozzle size on the outside of the nozzle, but is associated with the pressure flow dependency of each nozzle. Our nozzle capacities are defined as the flow rate in liters per minute at 20 bars multiplied by 10. So if you have a nozzle capacity of 200, this nozzle will give you 20 liters per minute at a pressure of 20 bars. This is one of the nozzle capacities that is mostly and most commonly used in industrial foam cleaning, because you need a lot of water to float away the dirt, and this is why they use larger nozzle capacities. The definition for the mathematicians and our viewers is as follows. So you have nozzle capacity is 10 times the flow rate, the German notation Durchfluss, divided by the pressure, the square root of the pressure. The nozzle capacity will always give you this kind of curve. So the nozzle capacity describes the pressure flow relationship, and this is mostly a square rooted relationship. This means if you want to have twice the flow rate, you need 2 by the power of 2, so 4 times the pressure. And if you have twice the pressure, you have the square root of 2, so 1.4 times the flow rate. In the diagram, you can see the comparison of the Lechler 632484 fan jet nozzle with a nozzle capacity of 50 and our OsciJet MPX-CS, so a parts cleaning nozzle, smaller one, also with a nozzle capacity of 50. The deviations between these two lines is due to manufacturing tolerances, but the identical curves denote the same nozzle capacity. So if you have a nozzle capacity 50 nozzle, it will always give you this curve. This is very important if you design a cleaning machine or a cleaning installation for a food industry plant, for example, because in your cleaning system, you need to hit the right operation point, and the operation point is depending on the curve of the pump, so the pump characteristics and the nozzle characteristics. You see here on the left side in darker blue, there's, for example, a pump characteristic of a centrifugal pump. You see you have a higher flow rate with a little bit lower pressure, or a low flow rate with higher pressures. And in the lighter shade of blue, you see the nozzle characteristics. So you see for about a flow rate of 220 liters per minute, you need 2 bars of pressure, and then it's going upwards. The intersection of these two curves is your operational point. So this is the point where your system will run. And if you now have the efficiency curve or the efficiency characteristics of your pump, you can see where your system will operate and how efficient it will be. The optimal operation is strongly dependent on these two characteristics, and this is mostly done by the manufacturer and designer of the cleaning system, because you mostly not only have one nozzle, but for a big cleaning system you have several ports, so you have several nozzles at the same time, so the pump does not always run in the same operational point, so you have to design the optimal range of operation for the cleaning system. When we now come to foam cleaning is mostly done throughout Europe in the food industry. In the US, there is still a lot of high pressure or pressure washing done in the food industry, but foam cleaning in the food industry is done due to the fact that you want to clean a surface and you want to keep it as neutral and without any germs on the surface as possible. If you use higher pressures, then you'll get small aerosol droplets will float in the air, and then after you've cleaned everything perfectly, those droplets will settle and they will sit on the surface and increasing the germ number on the surface again. So with foam cleaning, you use lower pressures between 20 bars and 40 bars, for example, and you use chemistry and foam to clean your system, your machine, and your complete plant. The foam cleaning is based on 3 steps, and I will show you the 3 steps, and I will show you in the center circle on the left side what are the main factors in each of these steps. So the first step is pre-cleaning. With pre-cleaning, you use a lot of water, and you don't use any chemistry use a certain amount of time to clean all the large chunks and all the dirt that is not so much stuck on the surface, to heat up the surface and to create the right surface for your chemistry. So the mechanics and the temperature are the two most important factors for the pre-cleaning, as you want to soften the dirt on the surface, rinse the surface the first time, and heat up the surface to get the chemicals in the right temperature range of operation. And the next step, you put foam on the surface. So foaming is done with very, very large nozzles, almost no pressure. You just distribute the foam on the surface and let it sit there for a while. So you use chemistry and time to get the dirt to solvate, to dissolve the dirt in your liquid, and to disinfect the surface. So you have very high pH number chemistry or very low pH number chemistry to destroy all the germs and to disinfect your surface. The problem there is afterwards you need to remove all the dissolved dirt and you need to neutralize the surface again. So the third step is rinsing. Again, rinsing, no chemicals, a certain amount of time, not as much time as for the foaming, and again mechanical energy and temperature. Temperature to heat up the surface, to get it dry, to let it dry fast, and mechanic to move away all the dirt, to rinse the surface of all the debris and everything that is left. So you want to rinse, you want to float away whatever is there, and you want to neutralize the surface so that you can run your plant again safely and disinfect it. The mechanical part, as you can see here, is the dominant part in pre-cleaning and rinsing. And pre-cleaning and rinsing are the parts where you need a lot of water because you need a lot of mechanical energy. So this is a part where you use a lot of energy to heat up the water and a lot of water, which is not very efficient and not very sustainable for the environment. What is currently used? Most nozzles that are currently used are fan nozzles. So the fan nozzle, as I hold it here in my hand, or as you can see it on the screen there, distributes the cleaning fluid along a line on the surface. They are also called fan jets. So they create a fan-shaped jet, distributing it along a line, and they're most commonly used in industrial cleaning. They allow to clean off large surface areas in a short time because you can move the fan on the surface and then you have a large cleaning area. What is our new nozzle? Our new MPX-CS nozzle, cleaning nozzle line for medium pressure and foam cleaning is designed with a very, very specific task in mind. In the center circle, you can see the potential. When it comes to pre-rinsing and to rinsing, you need a lot of mechanical energy. As soon as you have higher mechanical energy on the surface, you can reduce, for example, the temperature, or you can reduce the cleaning time because you have the same 360-degree circle, but with a larger portion of the mechanical energy. So you can have a faster and more efficient pre-cleaning and rinsing, and you can have a better heat transfer on the surface to have the whole cleaning target more efficient, or the cleaning task more efficient and more sustainable. What we need? We need an increased mechanical cleaning performance, and we need a higher temperature rate or a higher temperature on the surface created by the droplets. And as you see the picture, I think you know how to do this. When you use your garden hose to clean your patio, for example, or to clean your gardening tools and you have very, very tough dirt on the surface, you start to move and to oscillate the jet from side to side with your hand. Because if you have a droplet that is hitting a surface and you give the droplet enough time to move away before the next one hits the surface, you have a higher cleaning power. So this sweeping from left to right with your hand is nothing that you do to have fun. It is something that you do intuitively to create a better cleaning power. This is what people do by cleaning cars and so on, and of course this is what people do when cleaning industrial plants. They move the nozzles from side to side. Or they install mechanics to move the nozzle around. So the moving is what makes the big difference. What our nozzle does is we create the same movement without the need of any moving parts or without the need of moving your hands. So the state-of-the-art nozzle creates, in this case, what you see here is a jet nozzle or a fan, But what our nozzles, our OsciJet nozzles do, they create a sweeping jet. The jet is moving from side to side without the need of any moving parts. We can create better cleaning efficiency, we can save water and time, and we can lower the costs of operation. Of course, an easy handling is needed, and I can show you later how the handling of our nozzles is different and even better than for fan jet nozzles. But how do we do it? Our nozzles have a very specific geometry inside of the nozzle. You can see here a computational simulation, so a computational fluid simulation of the inside of one of our nozzles. Dark blue means we have high velocity areas, lighter blue or white means we have lower velocity areas, and the flow is coming from the left to the right. Even though it looks like it, the nozzle is completely filled with water. There's no air, there's no mechanics, there's nothing else inside this nozzle than water. And we use the so-called Coanda effect. This is a flow effect that means that jets want to attach and want to stream along a surface. So when the flow enters the nozzle from the left, we create a jet. And we give the jet two surfaces that it can attach to. So we have an upper block and a lower block. And due to the turbulence, it always starts on one of those two sides. And let's now say, for example, it follows the upper inner block. So it follows the surface on the upper side of the nozzle. And the main jet leaves the nozzle at a certain angle downwards. A very small portion is then transported back through the feedback channel upstream again and pushes the jet on the downward side of the nozzle. So we have a self-sustained oscillation which is only dependent on the geometry and on the flow velocity inside the nozzle. And now with our computational and optimizational tools, we are able to design the geometry of the nozzle to give you as our customer what you need. So we can design the spray angle, we can design the frequency, we can design the droplet distribution downstream of the nozzle. We can give you nozzles for air, for steam, for water, for gas, for fuel, whatever you need. And in this case, we created two distinctive nozzles for the industry cleaning and for the food industry cleaning to help you enhance and get more efficient in the pre-rinsing and the rinsing process of your cleaning task. How does this look in real life? Let me show you here with our demonstrator that we use for trade shows. In the upper part here, we have a nozzle which is connected to a pump. This is a plastic nozzle. There's no moving parts. It is completely steady. We use it for years, so it's not blocking. And if I start the pump, you see a fan jet, which looks pretty boring. This is the case because the jet here is oscillating from side to side about 50 to 60 times per second, so you won't be able to see it with the naked eye. But we have installed a stroboscopic light back here, and with a stroboscopic light you can see the oscillation. So you see the oscillation of the jet. The jet is moving from side to side, but it's moving so fast that you can't see it. But it gives you the higher cleaning power of oscillating your hand 50 to 60 times per second without the need of any moving part. So coming back to our slides, we can give you the features of our OsciJet MPX-CS and MPX-CS HF high frequency nozzle, which gives you an improved cleaning power due to the moving jet. The water distribution and the usage is almost identical to a fan jet nozzle, as you will see in a couple of minutes. You have very, very large droplets which hit the surface. If you put your hand underneath one of those nozzles, you will feel the oscillation. You have a high droplet velocity, you have less heat loss between the nozzle and the surface, and you can reduce your water consumption in your cleaning task. We have here, for example, a cleaning test which we did with a skillet. So we used a cast iron skillet, we filled it with grease, and we let the grease sit for 24 hours, and then we tried to clean the surface with two nozzles. One of them is a classic fan jet nozzle, one of them is our MPX-CS HF high frequency nozzle. You can guess which one is which, but I will show it to you. The one on the left is the fan jet nozzle, and the one on the right is our MPX-CS nozzle. So this nozzle on the left, as you can see, has left some debris. So in the cleaning path of the nozzle, you have some dirt left still on the skillet. and you have some larger chunks flying around. But with our nozzle, you have a completely clean surface. You have a larger area that is cleaned, and we use the same amount of water, we use the same pressure, and we move the nozzle along the surface with a mechanical arm, so it has the same speed on the surface, so we have a better cleaning power for the same water consumption. This means we can give you a smaller nozzle with a lower nozzle capacity, and you'll have the same cleaning power as before, but you can save water. For the heat transfer, we chose our MPX-CS nozzle in comparison to a classical fan spray nozzle, and we got our hands on an infrared camera to see the heat loss in the spray. As I start the video, you will see the thermal image on the left and on the right, and as you can see on the right side, we have about 1 to 2 degrees Celsius higher temperature around 20 centimeters downstream of the nozzle. The average thermal image, as it is shown here, clearly visualized the better heat transfer. On the right side for our MPX nozzle, you have the lighter, the more yellow spray, which indicates higher temperature than on the left side for the fan spray nozzles. Our larger droplets will keep the heat in the droplet and will transfer it more efficiently to the surface and will give you higher cleaning efficiency. As you can imagine, or as you might think now, 1 or 2 degrees Celsius, what does this mean? We have a calculation on our website. If you really look into it, 1 or 2 degrees of heating up the water throughout the year will cost you between 100 and 1,000 euros a year, just for the energy that you need to heat up the amount of water of 1 degree. So if we reduce the water heater by 1 degree, you can save a lot of money. The water consumption, as you can see here again, with the characteristics of the nozzle and the pump. The higher efficiency of our OsciJet MPX and MPX-CHF nozzle allows you to reduce the water consumption, which will give you the more efficient nozzle characteristic, which is shown on the gray curve, moving everything a little bit to the left. So you have low water consumption and you have higher pressure with the same cleaning power. So when you have a cleaning machine and you want to exchange the nozzle, just give us a call and we can tell you how much water you might be able to save and give you the idea of what kind of nozzles you need. We have 2 distinct nozzles for foam cleaning and for industrial mid-pressure cleaning. The first one is the MPX-CS HF, which is a very compact nozzle, which is made from stainless steel or brass, whatever you need. It has a spray angle of 30 degrees, and we can give it with nozzle capacities between 150 and 400. The standard nozzle capacity that is used in the industry for mid-pressure food cleaning is around 200. So we designed the 150 nozzle capacity to give you the possibility to save water and have the same cleaning power. The MPX-CS HF is compact and is ideal for film producing dirt, for example grease. So this is the one that we used on the skillet. And my colleague has built one in our test stand as we are on the lab. Let me quickly go over there and have a look on how the spray looks like. So you see our MPX-CS HF nozzle mounted up here. It will create a spray, a fan spray, as you can see. You can see on the water distribution inside the nozzle, and maybe you find the difference between the 2 nozzles I will show you, but my colleague will start it. It will get a little bit louder, so my voice won't be heard anymore. So as you saw, we have a fan spray nozzle. We have a very evenly distribution of the power with a little center jet for more sticky dirt. And this is the nozzle that we used for the skillet test. And this is the nozzle that we can point you to if you need it for very hidden areas because it's very compact, or to film producing dirt. The other nozzle that I would like to show to you is our MPX-CS. So this is the low frequency version. which is made from stainless steel in the same nozzle capacities. It has the same spraying angle, but it is a little bit larger on the outside, so it creates a lower frequency, and it will help you to pre-clean and rinse, for example, in meat processing plants. In meat processing plants, if you pre-clean it, you have debris, so little chunks of meat on the surface, and you want to spray and sweep them away. So this is why we designed this nozzle to have a little bit higher, a little bit heavier edges, so that your debris will stay inside your spray fan as you move it towards whatever you want to move it to. So now let me go over there again, and you can see the spray fan of this one. As you might see, the spray on the outside will be a little bit more heavy, the frequency will be a little bit lower, so you see the oscillation even a little bit in the start. And again, it will be a little bit louder, so my voice will go down. And a funny feature that you can see there at the end, when the spray goes down, it attaches to one of those sides, so you see the outer edge of the spray, and it's not oscillating anymore, because it needs a certain pressure to start the oscillation. Both of these nozzles are designed to work between 15 and 60 bars, so they will give you the perfect cleaning power for your mid-pressure cleaning. When it comes down to handling the OsciJet nozzle, you can see it here on the left side, cleaning a conveyor belt. Because the picture is taken with a flashlight, you can also see a little bit the oscillation. So the jet is currently on the downward side, and then it moves up. But the OsciJet MPX and the MPX-HF nozzles handle even easier than current nozzles. For example, you need a steady movement. You don't have to shake the nozzle manually anymore. You just need to sweep it along the surface in a steady and slow manner, and it will do all the job that you need. You can enhance the cleaning power with it getting closer. So we have a broader operational range. For example, for fan jet nozzles, you have a certain minimum distance from which the cleaning power will go down in both directions. So if you get too close, it will go down. If you get too far away, it will go down. But with our OsciJet MPX nozzles, you have the highest cleaning power if you get really, really close. So if you have a very sticky spot of dirt that you need to clean, just get really close to it. And if you just need to sweep around and rinse everything, you can go further back and you can have the perfect handling of the nozzle. And our nozzles are extremely robust. They're made from stainless steel. They are used, for example, in agricultural pressure washing for over 3 years now. We have a YouTube video that you can have a look into. This nozzle was used for about 5 to 6 months. It looks like completely destroyed on the outside, but it's still working perfectly on the inside. So they deteriorate a lot slower than classical fan jet nozzles. One other thing that I would like to show you today as well is our OsciNet system. The OsciNet system is the future of control because we were able to use the oscillation in our nozzle to create the complete monitoring system for your cleaning tasks. This first Nozzle 4.0 gives you the monitoring of water consumption, nozzle blockage and nozzle wear in real time during the task. So you can monitor every cleaning procedure. You can see how much water is needed to clean the same area. So for example, you can see if somebody's using too much water to clean a certain area. And it is economic and fully integrable. So we can put it into your system and you can use it to monitor your people, to monitor your cleaning tasks, and to get the most sustainable cleaning that is possible. How do we do it? We use the oscillation inside our nozzles. On the top left, you see one of our mixing nozzles, which is used for a gas turbine. And the frequency of oscillation inside our nozzles is linearly dependent on the volumetric flow rate. So we can monitor the flow rate in real time by measuring the frequencies. And of course, we have something like this created and ready. So let me show it to you. In here, we have a little bit of electronics, which is neatly packed into this plastic box to keep it watertight. And this nozzle measures the oscillation with a little vibrational sensor. So this electronics can be stuck to the surface of the nozzle like this, and it's glued now with double-sided adhesive tape, and it's falling off. So let me put it on again. You can see it measures the frequency, and you can see it measures the flow rate. My colleague will start the nozzle and will show you, okay, I will hold it for you, and will show to you the display, and will show to you our Coriolis mass meter, which is calibrated and measures between 1.5 and 2% of errors. And this one costs about 4,000 to 6,000 euros, whereas our OsciJet system can be built very economically. So as you saw, the nozzle oscillated at about 80 Hertz, and we have a flow rate of 1,210 kilograms per hour, which was the same as our laboratory equipment was able to measure and to detect. And again, the electronics inside this box will only cost you a couple of bucks. So with this OsciJet system, you're able to monitor and to see what's done with your nozzles. You can monitor the uses, you can monitor the nozzles, you can see tempering of the nozzle, and you can react before it's too late. But you can also see wear of the nozzle. So if somebody is using a nozzle that is going bigger and bigger due to wear, you can react and change the nozzle, reduce the water consumption again. It's also possible to reduce the water consumption because you can monitor the consumption. So basically you can give out a target, so you're allowed to use 200 liters of water to clean a certain area, and you can monitor it. You can have a little gamification in there, so you can challenge your users who is able to use the least amount of water, to clean the same surface area. With OsciJet, you not only have these medium pressure and foam cleaning, you have endless possibilities. We have nozzles for pressure washing, we have nozzles for low pressure cleaning and parts cleaning. We have nozzles for home and garden. So for example, if you live in the US or in Canada, you can go to Home Depot or to your local hardware store and you can buy the Melnor Impact nozzle, or the Impact spray gun, which is basically our nozzle technology integrated into their product. Throughout Europe, you can use the same for your home using the Gardena EcoPulse system. Our technology is integrated up there, so you can save about 40% of water for the same cleaning power when you want to clean your car or your patio. As already mentioned, we also have mixing nozzles. So we have nozzles for the perfect mix. Our nozzles create, due to the oscillation, a more homogeneous mixture and are used in gas turbines by MAN, for example, in a 7 megawatt gas turbine to generate power. This year we are developing, and we will certify it next year, our OsciProtect nozzle. So a nozzle for the agricultural use, reducing the amount of pesticides in the air and in the surrounding water, help you get agriculture more sustainable. The OsciJet system I already showed you, and with OsciCheck we are developing in a research project a non-destructive testing nozzle which is able to create ultrasonic pulses to test, for example, bridges and buildings without the need of moving parts and without the need of putting your ultrasonic generator on the surface. But there are endless possibilities. If you have any question regarding possible applications, feel free to contact me and we can discuss what's possible and what's best for you. Our satisfied customers are, for example, Gardena, Statico, Melnor, and a couple of others. And there are even more than the ones that I'm showing you here, because due to non-disclosure agreements, we're not allowed to show everyone. But as you can see, we have a lot of experience to manufacture nozzles from steel, from plastics, and to give you the nozzle that you need for your application. If you want to contact us, the point contacts for cleaning, or for industrial cleaning in this case, are Thomas Rossiger. He's our Chief Sales Officer, and he's our point contact for industrial cleaning, mid-pressure cleaning, and he has his expertise in foam cleaning. My colleague Jens Wintering is our Chief Production Officer, and he is our sales point contact for power washing. So if you have a power washer for agricultural or for domestic use, feel free to contact him and he will give you the right nozzles. And last but not least, there's me, Bernhard Bobusch, the CEO. I've specialized on special products or special questions. If you have any questions regarding this, feel free to contact us on our website. Book a one-on-one slot for a face-to-face meeting or a virtual face-to-face meeting in these times, so we can discuss your application and we can give you the possibility to test our nozzles and help make your machines and your cleaning tasks more efficient and more sustainable. Thank you very much for your time. I hope it was interesting for you, and I hope I'll hear from you in the near future. Have a good day.